is a official band name, by the way. It's not just for random people. Okay. So replace n with n plus 1. And then I can set up the ratio. And when you're doing this problem, don't leave anything out. Some of you guys did bits and pieces of what was needed. What is it that shows me you're doing the ratio test? How do you know I'm about to do the ratio test? Because I've written down a limit. Limit of what? Absolute value, good. Of the n plus 1th term divided by, now we can see it's going to be plus 4 minus 1. Is that cool? Is that all right? And then times the original shit just turned upside down. Yes? Okay, now, I want to focus on some of what's involved in what we're about to do. So the very first level skill you need is, can you just figure out what the n plus 1th term is? And it always sounds like I have like a list. When I say that, I have a list. The n plus 1th term. But it's just replacing n with n plus 1. Now it's, do you understand how factorial works? Do you understand how powers work, right? And again, it's not that you guys don't know how powers work, but there's kind of a lot going on. So you sometimes kind of lose focus, and you don't notice what parts of this are pretty straightforward. But in grading these, I picked up on the fact that we have some misunderstandings about how some of this works. So if you want to be really, really careful, here's what I would suggest. So I think most of you could get at least somewhat close to this. Then things went awry on the next step. So can you guys, by the way, I could reorder all this shit on the top however I want to. Do you guys agree? Because it's all multiplication on the top. And on the bottom, these are all dividing into these, but these are all multiplying each other. So again, I can order those however I want to. So what bits go together? What goes together with 4 and plus 3? 4 and minus 1. Do you have to do what I'm doing? No, because I didn't do it this way before. Can you, if you want to be really careful? Shit, yeah. What else goes together?
Factorials.
Yes. And then, of course, the x stuff obviously goes together. All of the stuff that I just did, they just are common. They have stuff that should cancel. All right. Somebody kind of with first bit. What happens with that first bit? The 4n business.
It reduces to 1.
Does it reduce to 1? Sorry, Sarah, I know what you mean, but be careful how you say it. The limit of that is 1. Why?
Because of ratio.
The powers are the same. So it's a ratio of the coefficients, like somebody was about to say over there. Yes? You guys with me? I think some of you guys didn't know why I was crossing through these. In the first 3 problems, I was trying to be very careful about putting like a 1. That means that that bit goes to 1. And we're stealing that stuff from pre-calculus, yes? That's the 3 things that could happen for horizontal asymptote? Okay. Do you guys, so this is part of what I mean when I say to people, be nice to yourself. The math is hard enough already. Be nice to yourself. You are completely allowed to rewrite the problem as long as you maintain what the thing wants you to do. In this case, I can rewrite all this multiplication in whatever order I want to. So I'm going to put all the shit that's related, and then I can focus. You guys kind of with me? Maybe? What happens here? Can I just cancel the exclamation marks? Hell no. That is equivalent to somebody saying, oh, the square root of 6 divided by the square root of 2, I'll just cancel the square root symbols. Are you guys, do you understand? Please tell me you understand this. Okay, good. You guys, pretty much I could see most of you guys. No! I cannot cancel functions because I'm dividing them. Yes? Okay. So I cannot cancel that exclamation mark. Is that cool? Because this isn't n plus 6 times exclamation mark. Yes? Because then you're like, I'm going to do 5 times semicolon. No. What does that exclamation mark mean, of course? If you start to rewrite n plus 6, how would you rewrite it?
N plus 6 times n plus 5 times.
Yeah, and then you get tired. So this is 1, yes? So I'm gonna, times 1, all this stuff stays the same. If I start to rewrite a factorial, it's where I start times 1 down from that. And that would go forever. But I'm like, no, screw that. And the main reason why I stop here is because it matches this thing and they die. They die, poor little guys. And of course I got my x stuff. What happens to the x stuff? How many x's cancel? How many x plus 2's cancel? N of them. Yes? And then how many's left?
1.
1. I had a few people that get stuck. A few people got to this point, but then he didn't keep going. What is the limit?
Infinity.
Yeah, as n goes to infinity, n plus 6 goes to frickin' infinity. But do you also, that's no matter what x is except for one thing. What could x be that would save that thing's ass? So this is infinity unless x is negative 2. So can somebody tell me what is the radius of convergence? How far can you get away from the center and we'll still converge? 0. Good. The radius is, what's the only thing that works?
0.
Negative 2. I love you guys. Negative 2, yes? That's the only thing that works. So you can't get away from it at all. You're stuck at the center, 0 radius. The interval won't be an interval. It'll just be a single number. And the way you do it normally, I'm okay with this. If you say this, I'm okay with it. Officially, an interval is basically a set. So your answer should always be a set. But if you just say when x is negative 2, I'll give it to you for you. Yes? Is that, you guys with me? Does that make sense? That is one of the 3 main things that can happen. Either one thing works, kind of like a finite radius thing works, or everything works. Those are the 3 things that could happen. Is that, we've seen each of those things happen. Okay, maybe. Oh man, so many guys look downtrodden. I just like that word, but I don't like what it describes. Oh well. Okay. Let me see if there's any other. Oh, who didn't get their quiz back? Let me catch up here. Oh, yeah, you put this is me. Oh, jeez. Oh, yeah. Yeah. Diaz? Is that everybody? Yeah. Okay. I think the average is like 80 something, 82 around there somewhere, and there were no Fs on this thing, by the way, so that's pretty good. There were a few Ds. You guys can make corrections. Okay. Okay. So, and now that more people have the quiz back, any other questions from the quiz? All right. And everybody's got a practice test? David, what's up? You need? Huh?
What'd you get this?
Last time.
Oh.
You got one? Okay. You got it. All right, guys. So let's focus on this for a minute. I'm going to build up to a question that I was helping some students out with earlier. That it's a little bit of a trippy one. There will always be some trippy problems in the homework I give you, because I want to push you a little bit.
In which homework?
I can't remember what section it was from, but you'll tell me in a minute. But before we get there, let's just talk about some things specifically. For for example, let's say I've got this. What you got, Jeff? Write it down. Yeah, well, let's say I've got this. No, let's do, yeah, sure. Okay. Let's say I've got that. It's not too bad. Actually, I'll even tell you one more. Let's put in there this too. Okay. So if I would have planned ahead, that would have looked a little better. Too bad. It's the leaning tower of math problem, okay? Can you guys take a moment and write out what an plus 1 is? I'm going to do like a... Do y'all agree that ratio test is a pretty good thing to determine if this converges? Factorials are weird to work with. They are very straightforward with what they mean, but can you even start to imagine trying to take the derivative of a factorial? You guys can you guys just take a moment and consider what would n factorial derivative be? You start, yes, do you know what it is? Oh, okay, sorry. I was really excited, like, okay, shit. This is some weird shit. The factorial, does everybody agree with me, it's really defined very, very basic. What is 28 factorial? How would you start to put that in your calculator if you had to do it all the way up? 28 times 27. So the idea of it is stupid straightforward. But we've never seen a function defined that way, have we? So it doesn't work as simply as almost any other function we've ever looked at. We've never had a function defined where it has as many pieces as what I'm throwing into it is. Do you kind of see what I'm saying? We've never had a function that grows how many terms I'm looking at based on what you put into it. You guys kind of with me? So how many terms does n factorial have? I don't know till you tell me what n is, right? Okay. But if I said how many terms does a cube root of n has, you're like one freaking term, dude. You just said it. So I almost definitely want to use a ratio test when I'm dealing with factorial because a ratio test allows me to cancel this repetitive part. Now here's where people make mistakes. This kind of encapsulates a few mistakes I saw. Can you guys just take a moment and write out what an plus 1 means? What is an plus 1? Just write it in. If you have paper. Yes? Those. I'm sorry, it was me about to write something. Here, I'll write it over again. Again, I am just amazed I am standing up right now. I started to write something and I changed my mind, so that's what we're working with right there. Look at this.
That's what one said.
Basically. So now I'm going to make 3 sips out of it.
How come calculators can't graph factorial?
Well, because, again, how do I say this? 2 reasons. It is a discrete function. So it doesn't it's not something that would be connected. The output is based on what the input is in a way different from any other function. So it has to know, all right. Does that kind of make sense so far? There's a little more to the story, but okay. So of course, this is what they gave us, and they is me. That's an. So what is an plus 1?
4 n plus 4 factorial.
Yeah, let me do it really all the way out so everybody sees everything. So replace n with n plus 1.
Over 7 n plus 1 times n plus 2.
Good. All right. So that's replacing n with n plus 1. So that's the first level skill, right? Just throw an n plus 1 in. So here's where, kind of understandably, things go awry. So if I build this ratio, so now I can write this as 4n plus 4. Is that cool? All right, so that's an plus 1. and I multiply that, because I'm supposed to divide by this, but I just multiply by the reciprocal. I think everybody's pretty cool with that idea. Okay. So one thing that not a lot of people did was they kind of went the wrong way. So when you rewrite a factorial, which direction are the numbers going? Down. They're getting smaller. Yes? Okay. So I'm not going to rewrite 4n factorial. Yes? Which of these has more terms?
The 4n plus 4.
Yes. This one's got more terms. Yes? Okay. And I had people distributing this thing. Why is that a bad idea?
Because then stuff does not cancel.
Yeah, so let's do this first thing. And again, you don't have to do what I'm about to do. First thing I'm going to do is I'm going to start to consolidate everything that's built on the same idea. Because those are the things that are going to interact the way that we need them to, right? So what can I put next?
Factorial.
I got those.
Oh, you already have factorials.
The 7 stuff, or maybe let's do the 7 stuff. And then the n stuff here. Just the basic linear stuff, yeah? Is that cool? You don't have to do that. But do you see how that really focuses you on what parts are going to affect the other parts? Because some people are kind of losing stuff, which is easy to do with a lot of stuff going on. How do I rewrite this top?
4n plus 4
Yeah.
times 4n plus 3 times
Good.
4n plus 2 times 4n plus 1 times 4n. Factorial.
Why did I pick 4?
I don't know.
Okay. The basic idea of factorial is it goes down by 1. The factorial doesn't give a shit how the stuff on the inside was created. Whatever it ends up being, if I want to rewrite it, it goes down by 1, down by 1, down by 1. Yeah? So I had a few too many people that would write 4n plus 4 times 4n. Like what happened to all the steps in between? You have to go down by 1. Okay. And then I know I'm going to stop here because then these will cancel. If I wanted to rewrite this just to really show myself what's going on, how do I rewrite 7 to the n plus 1?
7 to the n times 7.
Yes, because I add powers when I multiply like bases. And of course this limit is going to be,
1.
I don't want to rewrite that because I'm running out of room for one thing. Do you guys see that? Do you guys see all the parts that go into this? And again, when you're learning something, and I didn't think to do this, just because I was hoping we could kind of see what was happening. When you have fractions, whatever's common, I just kill it from the top to the bottom. But you could reorganize the top and bottom so you can focus better, right? So what cancels? We got
4n factorials and 7
Yeah.
to the n.
So real quick, you do not, dear God, do not multiply this shit out. But what would the degree be on top if I did?
4.
4th degree, and the bottom is
0.
nothing.
1, technically.
No, 0 if, because it's a constant, which has no ends. Yeah. So what's this limit? The top is stupid big. Infinity. Which means what about the series, of course? Divergence. And some of you guys should have from the beginning, you could tell. That grows pretty fast. That beats it. Especially because of this dude, but that beats it, yeah. Is that alright? No, yes. Factorial is one of the fastest growing things. Yeah.
I have a question. I know it's not canceling, but the part where it's n plus 1 over n plus 2, you do that arrow, is that because when you keep n to infinity?
Yeah, the limit of this is 1. Yep. That's it. Okay. So these are not canceling. Of course they're not canceling. They're not the same dumb thing. So they can't cancel. But the limit is 1 because the degrees are the same. So they're growing lockstep. Yeah.
I get the answers, but how come you can take the limit of that part of the problem and then keep the limit of the rest of the problem?
Okay, you ready? So everybody, I'm sorry. Did you guys get that? Everybody was playing along? Okay. So help me out here. You ready? Let's take a step back in time. Bless you. How would you take that limit? Plug a 2 in. Would I be wrong? Can anybody see what I've done here? You have to write it, Jeff. What did I do? I put a 2 into this one, but nothing else. You with me? Is that still true? Of course it is. Because now I can just plug a 2 in. Now, some of you guys are like, just plug a 2 in everywhere, Jeff. My point is, could I do this if for some reason I wanted to? You with me? Hell yeah, I could. Because the limit of the product of continuous functions is the limit of each function individually multiplied. So if you have continuous functions, you could do all kinds of shit with the limit. Yes? Okay, maybe. The only thing that you have to be careful about is if any of these went to infinity, you can't do what I just did. And it makes sense, because is this continuous at 2? No, okay. So as x goes to infinity, or in this case n, every piece of that function I'm looking at is continuous. Because my n never gets to infinity. It gets really big, but who gives a shit? If I want to plug a 2 into a function, it's functionally the same as plugging 17 trillion to the trillion to the trillion to the trillionth power. They're both the same process. Just one of them is going to be really big. Yeah. Does it make sense? So that's why I'm allowed to, thank God. Because if I can identify that shit, I got less to look at. Yes? So I always look for the parts that are effectively polynomial parts. Because then I can just apply precalculus to them. I can say, oh, they're the same degree. The limit's 1. Well, you know, the coefficient of the ratio of the coefficients. Okay. Is that cool? So that's why you're allowed to do it, because at every n, it's continuous. So I'm allowed to take the limit of each piece if I wanted to, as long as I maintain the multiplication. So when I get a 1, it's multiplied. That doesn't change anything. Okay. Is that all right? So if I were you, I would seek this out, this kind of thing out, and just let that limit become whatever. That's less for you to worry about on the next step. Because I think part of the problem with this is that depending on what this looks like at the beginning, you're going to have a ton of stuff kind of like to play with. Yeah? There's going to be a lot of parts to look at. And any parts I can get rid of, hell yeah. Sorry, I'm tired. Okay. Anything else from the quiz? So now I'm gonna open it up. You guys got questions? There was a question we were working on earlier. I think I want to hold off on it for a little bit. See if we get any more basic questions, and then we'll do that one in a little bit. You guys have anything from the practice test? Anything from homework?
11, 9, 18.
Which one?
11, 9, 18.
Okay.
I started it and then passed up.
$18? So find a power series representation for the function and determine the radius of the convergence. Now in 11.9, we haven't learned the Taylor series process. All we know in 11.9, really all we know is the 1 over 1 minus x, this guy. So if I said x over 1 minus x, I would just take this and multiply it by x. So those kind of modifications that we talked about, if I have a series that I know, and I have a modified function, I could just modify the series. Is that okay? Screw you, Jeff? Okay, so for example, a simpler example, real quick. I know that 1 over 1 minus x is equal to this in certain circumstances. If this is less than 1. And that is just geometric series replacing r with x. So then I make it a function of x. So 11.9, come back to me. No. Thank you. 11.9 is using something we know to show a connection between a function and a power series. 1 over 1 minus x is a function. It's a function of x. Because of the form it's in, I can connect it to a power series through the geometric series, yes? And so that's why I could write it like that. So this is what I meant by we kind of fell backwards into this fact, that there's a way to take a function and write it as a power series. 11.10 is where we take that idea and we blow it to shit up. And we're like, you give me any function, I can try to start making a power series out of it, right? The Taylor series, Maclaurin series, you guys kind of with me? No? We try to speak.
Are you ever? What you say?
Are you ever with? We're physically in the room with each other. All right. Something really, really cool. All right, real quick. Can you guys remind me, if I do have a power series like this, I'll make it look the same way as it did before. What is the sum of that power series? Let me put this in here. There. Yes?
And you don't go 1 minus r.
All right, now, what about this power series? What's A?
1.
1. All right, now what about this power series? Is everybody cool? That definitely sounds familiar, yes? Okay, that is completely familiar. This is, you kind of at least watched me prove this. All I did here was I made A 1. I gave A a specific number, and there you go. So now A is 1. And now I'm going to do this. If I start at 0 instead, when n is 1, what is the power?
0.
If I start at 0 instead, what do I want my power to start at, to be? N. I really want you guys to see this. When I make n 1, the power becomes 0. What if I wanted to start at 2? Wouldn't this have to just be n minus 2? So that I have a 0 to begin with, yes? Do you see how you got to be with me? You got to be with me. Because we're going to be doing this shit pretty soon. If I plug a 1 in, I get a 0. I must have a 0 power in the first term. What tells me what the first term is the value that n starts at. So if I make this start at 2, I need to make this n minus 2. Otherwise, I have a different series. Is that cool? So if I make this start at 0, now I want the power to start at n so that the power starts at 0. What would this sum be? Aren't these the same? These are the same, yes? So what's the sum?
1.
Cool. So what if this is what I'm talking about? Poor little infinity. Yes, so then I can say 1 over 1 minus x equals this. And that's where that came from. That's just... r can be any number between -1 and 1. So then I say, oh, let me make it a variable then. It's whoever can pick. I'm just going to tell them, hey, you can only choose absolute value of x less than 1 or else this thing goes crazy. But you can choose whatever the hell you want between those, right? So I make it a function of x. See if we can really get 11.10 is a very stepwise way to create a power series given a function. Are you with me? That's the whole idea of telling. We take a bunch of derivatives, we evaluate them at the number I give you, and you put together the coefficients, blah, blah, blah. Yes? And I will give you the form of the Taylor series on the test. Are you with me? Okay. This was going, hey, it looks kind of like a function. We just replace r. So this is what I mean by we fell backwards into it. We didn't create the series, we just went, if you make it x, then it's a function. Oh yeah. So it was kind of like supposed to be a spark of like, oh shit, can I do that with more functions? This function just happened to be equal to a power series? If I have a different function, could it be equal to a power series? And 1110 says, shit, yeah, man. Okay, maybe. And then you can do all kinds of funky stuff. And the very first level of stuff we did was to realize the connection between e to a complex number and sine and cosine. That is very tricky. That is not anywhere near what somebody would call obvious. And we would never know that connection was there unless we had something like this. So it's really cool. So many functions you work with have a power series representation, and then you can make these connections between them you could never make any other way. Maybe some of you guys are. Now, am I saying you're going to have to do that? No. I am saying what we are studying opens that frickin' door. Okay. So coming back to your actual questions there, you've been very patient. I appreciate that. Where'd it go? Which one was it again?
18. It's x over 2 minus x all cubed.
Get in there. So real quick, first thing I'm going to do. All right, let's do this. Let me build you up to this. And I'm pretty sure they give a few examples in here, but let me kind of show you. If it was this, what's that power series, of course?
N equals 0 to infinity of x to the n.
Yep. And of course we know the x's has to be less, the absolute value of x has to be less than 1. Is everybody with me? That's the shit we already know. Now, here's the first level modification you have to realize how to make. And in fact, let me come at this a different way than what I was just about to. And you're all like, we don't know what you're about to, did you just do it? Okay, I'm sorry. What if I had this? What have I replaced x with?
X over 2.
Can you not say a word and write what the power series would look like? Based on what the hell we just said. If it's 1 over 1 minus x, power series is x to the n. Holy shit. Sorry. Yes, sir. This is the part that's really more powerful. On one level, I need you to accept that that's silly. Of course. If I made x 0.5, wouldn't you just plug a freaking 0.5 in? So I made x over 2, so I plug in x over 2, and what do you do, right? So on one level, it's like, well, duh, and that's where I want you to realize, that's all it takes. But on another level, we are creating new series based on new functions from something I already knew, and I don't have to do anything. I could just plug shit into what I already know. Okay, so let's get one step closer. What if I had this? What's wrong with that? Why doesn't that match the format it needs to? Has a 2 instead of a 1, right? It's 1 over 1 minus blank equals the sum of blank to the n, yes? That's the form. That is not right. I can't use this form to get me there. But Sarah's got an idea. What's your idea?
Take out a 2 from the bottom.
I'm going to say it a different way. You ready? I'm going to take a 1/2 out.
Take out a 1/2.
Yeah. So the 2 comes out of the bottom. Is that cool? So 2 divided by 2 is 1.
Minus 1/2 x.
And then we just do that one? So wouldn't this be 1/2 the sum, blah, 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 yes? Let me write it out, sorry. Do you guys start to see what it takes to understand what modifications to make to the sum that you know? One level of modification is easy as shit, just whatever's in the place of x, put it in. But the other level of modification is, it's got to be in the form 1 over 1 minus, right? Now, with that said, what is the derivative of 1 over 1 minus x? Yes, negative 1 over, well actually, be careful. You ready? If I take this guy's, let me do this more. There's something a little bit wrong here. Listen. If I take this guy's derivative, it's -1, yes? So -1 will come down in front of 1 minus x to the -2 times -1 because of chain rule. Do you guys see that?
Yes.
Negative because the power was negative. Negative because the inside was negative. These two negatives.
Cancel.
So this should be, yeah. Is that all right? What do you guys, how you guys doing? Do you know how to take the derivative of a power series?
Yes.
Yes. Can you guys just take a moment and do the derivative of this power series? Don't say anything. This is trying to be an n, by the way. Who's got that?
And x to the n minus 1.
And what's the convention we do here?
1.
Yeah. And really, it's just because if I left it at 0, the first term would be,
X to the -1. Negative.
if
x
n was 0, what would the first term be?
Oh, 0.
0. So we just start at 1 instead, because why would you include 0, right? You see, so if you took 50 derivatives, the first 50 terms would be zeros. So then you would just start at n equals 50. Do you see what I'm saying? Okay. So it's not necessary to be honest, but we just kind of do it. Because we just don't include the zeros. It's very cool that we've done that kind of thing before. How does that apply to what the hell we're doing now? I don't freaking know. What was this in function form?
1/1 minus x.
So then 1/1 minus x prime is this, yes? But it's also that. So then this is equal to this. If I know what 1/1 minus x is in terms of a series, then I know what the derivative of 1/1 minus x is as a series. So just to show you a little more straightforward. Here, 1/1 minus x is this. Poor little x. So what is 1/1 minus x prime, which is 1/1 minus x squared? It would be whatever I do to one side, I must do to the other side, right? So if I take the derivative of one side, I've got to take the derivative of the other side. Do you guys see what I'm saying? So real quick, do you see how everything we just went over goes into figuring this weird ass shit out here? I have a third power on this, yes? Which means I'm going to have to take one more derivative. I took one derivative and I got to a what power? Second. So 1 power is cubed. Does that make sense to myself? The top is what though?
X.
Good. So I would highly recommend you do this. So what you can do, you ready? Oops, get that in there. This is x cubed times 1/2 minus x cubed. Yes?
Yeah.
If I can figure out what that series is, I could just multiply 3 more x's into it. Yes? You guys with me? So here's the thing. Step 1 is, do you see the work it takes? Step 2 is, can you do the work? So this is all about what work will it take to answer this crazy ass question. We have to build up to what it is. I'm starting with 1/1 minus x. See the 2 that's in there? I'm going to eventually have to take a 1/2 out. You with me? Or something out to take care of that. Do you see the x cubed on the top? I'm going to multiply the n by x cubed. Do you get? So this is a good problem because it's got a lot of those adjustments all at once. But for me, I'm going to pull that shit apart. Yes? Now watch this. What are you going to do, Jeff? I don't know.
So would you start with the derivative?
Do it again.
Would you start with doing the derivative of that?
Yeah, totally. There's a few different ways you could do this. You could start with Here's one way you could do this. How would I do this? Yeah, I would maybe do that. If you start with this, let me think. What's a cleaner way to do this? Nah, screw that. Oh, yeah, you could totally do it. Okay, sorry. If I start with this, I can then take derivatives of this. Is everybody with me? Yes? So what am I trying? All right, let me make sure you guys are with me. If I start with this, didn't we just figure out what that looks like in a power series form?
Mhm.
What's it look like in power series form?
One half times the sum
This two
of one.
of x over
It's over
2
two.
to the n.
Right? If I take two derivatives of this, what power will I end up with on the bottom? Do you see how you are? What do I do with something I know to make it look like the shit I don't know? If I take two derivatives, it already looks like a lot closer to what they're asking me about, correct? The bottom will be 2 minus x cubed. You will get a constant. We don't give a shit about constants. I can make those work. Yes? Maybe? No? Screw yourself? Okay. And then the top, you're going to need an x cubed. Well, that's the end. That's the last thing I do is just multiply what I get by x cubed. So that's the beautiful part. If all I have is a multiple of x, some powers of x added in, that's awesome. I just have to multiply my series. So what do I mean? We did a few examples of this before. Do you guys remember what sine x is as a series? I don't know if you guys remember. Here. Don't worry, I'm not going to make you memorize this, by the way. I'll give you this table. I think it's on page 804. Sine x is the one that starts with x and it has all the odd stuff going on. So let me write down this guy. Uh, 2n plus 1, yes. Yes. Oops, sorry. So what would this look like as a power series? Power series. Here's a weird thing. What's the top? Top is this shit, yes? Beep, 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 beep. That's what sine x is equal to. Over x squared. And then don't I have just a bunch of x's and with powers that I know what to do when I divide? Do you guys, aren't I? Let me do it like this. Ready? Yes? What do I do with the powers when I divide like bases? What do I do with the powers when I divide like bases? How many x's are on the top?
2n plus
2n plus 1. How many I'm going to subtract off?
2.
So it's 2n plus 1 minus 2.
2n minus
2n plus 1 minus 2. 2n minus 2. Cool. I heard you too, sir. You're good. Do you all understand that if the only modification that was made is a divided or multiplied by x to a power, you just silently go, thank you, math gods. Because then all you have to do is throw that shit in. If it's divided by, I'm going to subtract that many x's. If it's multiplied by, I'm going to add that many x's. That kicks ass. That is one of the two types of modification, well, three. I could either multiply by x to a power, I could take derivatives, or I could plug something in like x over 2 like we did earlier, right? Those are the three kind of modifications I could do to construct a new power series without going through the entire 1110 process. Dear God. Do you want to go through the 1110 process for this? No, I don't want to take this guy's derivative. Are you kidding me? And the numbers it would give me? I would never get here. So I'd much rather start with something I know and then make modifications to it. So we can get power series for every function you've ever seen. I want to say that very carefully because there are some that we can't. Therefore, I can make a power series out of any product or whatever of any function you've ever seen. Without having to go through the Taylor series steps, yes? You all agree that the Taylor series steps are kind of long? Hell yeah. Okay. They are. So if I don't have to do them, yeah. But I'm still going to make you do them. Well, because that's what everything is based on, is that process. That got everything started. Without it, we wouldn't have shit. So you guys have to know kind of like how to apply it. Okay. Is that cool? That was a lot. You asked that question, right? The two minus x cubed thing?
Yeah, I'm making that. So we would start with the 1 over.
Yeah, there's a
2
few
minus
different
x.
ways to start, but I think I
Doing
would
it.
start that way. Yeah. So if you can start with a function that you know will become what you need, then you write what its power series is, and whatever you do to it, you do to the power series. Ba, 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 ba. That's exactly what we did. We had, wherever I have put the papers now. Yeah.
Okay, so I'm taking the derivative and I get for the bottom, I start at the first power.
All right, so let's see the
and then
first
go to the
steps here.
second, and
So
then
if I
go to the
start with,
fourth.
so I'm going to start with this. I wrote this down somewhere. This is just x over 2 to the n. Okay, right? Take a derivative. What's this guy's derivative? Oh yeah, now it's being overly cautious. I don't think we're going to have a problem here. Do you guys see what this guy's derivative is? Based on what we just said earlier. So on the side, if you do 2 minus x to the negative 1, what's this guy's derivative? Negative 1, 2 minus x to the negative 2 times negative 1. So it just becomes 1 over 2 minus x squared. And what happens on this side? And by the way, how can I rewrite this so I can see what's going on a little better?
1/2 times
Well, this is x to the n over
2
to the n. So when I take a derivative, what's the only part that gets affected? The x part, yes?
Yeah.
Okay. So what's this guy's derivative up here?
And
And then we go 1 to infinity, yes? Do you guys see if I do one more derivative, the bottom will match with the original question, yes? Because what's the original question have as a power on the bottom? Cube. One more derivative and I got a freaking cube on the bottom. In fact, my bottom is perfect. Very strange phrase, but the denominator will become perfect after one more derivative. I need you guys to see that. The question, the original question was, what the shit is this as a power series? That was the question. Do you guys see how one more derivative, I'm going to get this, aren't I? And then all I'm missing is this, but that's the easy part. I just have to throw 3 more frickin' x's in there. Just have to multiply by x cubed at the end. So if you can figure out what 1 over 2 minus x cubed is as a series, just multiply by 3 more x's and you're done. Maybe?
do we, are we gonna keep it as n equals 2, or are we gonna have to work backwards?
I mean, one more derivative, it'll be n equals 2, yeah.
Yeah,
You're not going to do work backwards or anything, because then you are where you want to be.
but do we wanna make that back into n equals 0?
You don't have to.
Instead of, okay.
You could. You don't have to.
So with this, if you multiply 3 x's back in, it would be.
Yeah, like, let's say the problem was this. Let's say the problem was, what's this? Let's say that was the problem, right? And they're like, hey, you, calc student, yeah, you barely know this shit here. Do this. And you're like, oh God. By the way, this is trippy stuff. And this is why what I need from you is questions. I need to know where things are not going right. Otherwise I can't really help. So let's say that's the question instead. What is the only thing I'm missing from where we got to? So if that was the question, I'd be done.
Right,
But I need to multiply this by
X squared.
x squared, so then I better multiply the other side by
X squared.
x squared. And I'm going to purposely do this. And then that, of course, can just go in, because according to the summation, that's just a constant, right?
7n plus.
Yeah, so then it became x to the n plus 1. You're just throwing 2 more x's in. You guys see that? That's almost too nice to believe. So the best modification in the universe is if they just take a function I know times some power of x. Then I'm like, little tears come out of me because I just gotta throw that shit in. Okay, maybe? Thank you.
The separating is really hard.
Good. So it's hard for me to tell what part of the problem gives us issues. After this quiz, I can tell better. Because I haven't seen much work, so I'm not sure where people are losing touch with what's going on. Okay. So, I mean, we're now in the wide open phase of the night, by the way. I mean, we're getting ready for the test. The test is next Tuesday, yes? I've got the answer key for the practice test. I'm not going to give to you yet because I'm evil. So we can do whatever questions you want. You got questions in the quiz, you got questions in the homework, yes, and then on the practice test? Okay. Did everybody get one of these? Want to check in? You need one? Okay. Oh yeah. Let's do this one. Wait. So what was it? 11:6.
Number 40, the last one, whatever it was.
Number 40, last one. Okay. All right, I'll look at it. We'll do a problem from 11:6 here in a minute. This one is a nice one to do right now before we get too deep into stuff. This one here, right? 2A? Yeah. Okay. Before, if I give you a series and I just am like, does this converge or diverge? Before you start trying to figure out what test to apply, whatever, what is the first thing you do, especially when you're like, that's not a P-series, that's not a freaking geometric, it's got freaking code change, what's wrong with this guy? What did I do? Who hurt this guy? Jeff, who hurt you? What do you try? What's the ultimate thing to try? If you have no idea and you can't really see what it is, and you really should try this first all the time, unless you're like, oh, it's a P-series, who gives a shit? What do I try? Test for divergence, which involves what? Take a limit, and everybody that has not done this yet, take the limit as n goes to infinity of the cotangent blah blah blah. Oh wait. Is cotangent continuous on its domain? Yes. So therefore I can take the limit inside. And the inside is just polynomial over polynomial. Good. Don't forget the other number in there though. Yeah, poor little pi dude. So if I do the limit, but does everybody understand what I just said? If you're looking at a series and you're like, I don't know what the hell this guy wants from me. It's not this, and just try to take the limit. If the limit's 0, then you're back to square one. You're like, shit. Well, let's see, right? Then you try ratio test. That's normally a good default if you have no idea what else to try. On this thing, not a damn thing would work. It's got a freaking cotangent in the way. None of our shit's gonna work. So I'm like, holy shit, let me see. Dear God, please let this be not what? What do I want this to not be? I don't want it to be anything other than 0. Because then I know I'm done, right? You guys with me? Getting 0 sucks for the limit of a series elements. That sucks, because then you're not done. That's the beginning of your work. If you don't get 0, you're done. It diverges. Yay. So Stephanie, I think you said what this was. 3 pi over -9. Now, this is where some of you guys are going to give me decimal answers, and you're going to lose maybe a point. I'm not going to go crazy, but that reduces to an angle you should know some shit about. Yes? What quadrant am I in?
Uh, 4?
Good, because you go back pi over 3, yes? You could break that down into what over what. Cotangent is what trig over what trig. Cosine over sine, I like it. Well, I'm sorry. I'm in the fourth quadrant, correct?
Yeah.
So the
Yeah.
cosine is the x part. It's going to be
Positive.
positive. And the sine
part's gonna be negative.
is negative. Bam. So now I've taken the problem and I've made it into a very basic trig problem, which some of you guys are going to look at me and say, that didn't help me, John. I'm like, damn. What's the cos? Oh, sorry.
You can do that, but we got the right side.
Oh, yeah, sure. Cosine likes x. So at negative pi over 3, cosine is positive. Sine likes y, negative. Again, one more example of how SOHCAHTOA sucks. If you just learn that cosine likes x, sine likes y, a lot of what you have to do after that makes more sense. Cosine of pi over 3, and again, cosine likes x.
3 over 2?
The further it gets away, it's going to hate it. Pi over 3 is a big ass angle, yes? So cosine don't
Oh,
like it there.
right, pi over 6.
Cosine don't like it there. So cosine is just
So
going to
it's gonna
be
be 1/2.
1/2.
Or root
Sine likes y. Pi over 3 is 60 degrees, is close to the y-axis.
So
Sine's
root
going to be
3
big. So the top is going to be 1/2, and the bottom is going to be negative.
Yeah.
Become a 2. And then the 2's,
are
the
gonna
2's
cancel.
cancel.
So then
And then you could rationalize, but if you get that far, I'm happy. Yes? What does that mean? You don't have to rationalize it because I don't care what the answer. The fact, all I need to know is this is not
0.
0, which means what?
it diverges.
Diverges. Right? Leave me alone, Jeff. Get thee behind me, Jeff. Okay. Yes.
So why can't you take the limit of the inside of the function?
Oh, because it's a continuous function. And we do that all the freaking time. Here, watch. What is the limit as x goes to pi of cosine x?
-1.
Yeah. Then you just throw the limit inside the cosine. Now you don't look at it that way. You look at it as putting a pi into x. But how did it get there? The whole thing must have gone inside. So that's the same thing. If it's a continuous function on its domain, I'm allowed to take the limit into it. Okay. And that's a little thing from Math 180, but whoever your Math 180 teacher should have been made a bigger deal out of that, because that's kind of like continues forever. Just this idea of when am I allowed to do that shit? Okay, so let's come back to the question from 11.6, number 40-something. 46. Oh, there was another question, too, that was asked earlier.
It's the same question.
Is it? Okay. This? No.
No, 11.6.
11.7, that's not where I am, Jeff. 40. This one? No. This one?
Yeah.
Oh, okay. So this is different than what I was thinking about. By the way, this dude, here for those people at home, that guy, Ramanujan. He's insane. He did a lot of shit. It's a name you guys don't know. I'm almost certain almost nobody here knows that. You know? He did so much shit. He did a lot of shit that is at a level that a lot of students don't make it to. Because you have to kind of like major in math, and you know, not a lot of people do. He did some amazing. Even if you do major in math, you could just never hear about it. Sorry, none of that is necessary for you to know. Look at that. Are you excited about this? Notice if I just put 2 plus 3n, and I put that a 3 there, wouldn't the whole thing look better? So part of the reason it's daunting is because the numbers are big, but they're just stupid numbers. So if I made each of them 3, 4, and 5, this problem would look a lot better, yes? Yes? Therefore, this problem is a lot better than it looks. So let's see what they're talking about. This dude proved that 1 over pi is this. Which, of course, we all can tell. It makes sense. No. No, I like somebody who's like, sure. No, this is not making damn good sense. But it's just true. Okay, so what do we have to do with this? We have to, where's my fingers? There they are. We have to verify that the series is convergent. So, I need you to understand when it is the numbers that are making it look difficult. 4n factorial times linear thing, yes? Do you guys see that? So that's like 2 plus n. You with me? 4n factorial. We've done that shit. We did that shit earlier today, yeah? Times 2 plus 3n or something. Yeah, that's just the linear thing, yes? That's like 2 plus n. Yes? The numbers are big. Who gives a shit? N factorial to the 4th. Okay, that's a little bit trippy. We'll look at that. And then that's just number to the 4th n. That's just, you guys kind of with me? Yes?
So, when you do have a factorial to a degree, the degree goes with the factorial. the whole
Yes,
time,
in
right?
fact. So, here. One thing you could do, if you need to, let me give you a suggestion. One thing you could do, number one is, I don't have to worry about this business out front. Are you with me? Because the question is, does it converge? So any multiplier is not going to make it diverge. So I can ignore him for a moment, yes? All I care about is the series part. So watch this. What parts of this kind of freak us out a little bit? The big ass numbers. So I'm gonna do, I don't know if this would help you guys. I was gonna replace it with A and B and so forth. That might make it look worse. I don't know. So we're just gonna leave the numbers. Okay. If I need to show this converges, even if you're like, what the shit's going on with some of this business, what do you obviously use?
Ratio,
Why? What makes that obvious?
because of factorial.
Because of factorials, yeah. Ratio test eats them up for lunch. They got all these terms and ratio is like, ah, yes? Yeah. Maybe. Okay, so we can do this one together. So I need to write replace n with n plus 1. Are we at a good place where you guys see that that's what that's going to be? Replace n plus 1, the 4 comes in, 4n plus 4. Then this becomes 1103 plus 26390 n plus 1. Is that cool? All over n plus 1 factorial to the 4th. And of course, the king of freaking leaving no room for anybody. Holy shit, Jeff. Let's see if I can do this. Oops, I didn't mean to put that there. Damn it! Pretend like that's not there. Okay. So that's the n plus 1th term, yes? So one level of why this problem sucks is because it takes a lot of writing. That I can agree with, right? Anytime I have to write more than I normally have to is bad because I can't write. Now I just write all the same business, just reversed. But include all of it, Jeff. There we go. Whoa! That still looks horrific. Yes? Okay. Can you guys, all right, real quick. Okay, let me do this. Let me write this so that all fits a little bit better. I'm going to start to, here, first thing I'm going to do, before I try to simplify anything, I'm going to start to collect all my stuff that should work together. What should I put underneath this guy? What's going to work well with him? Him, yes? Do you see that? So the next step, I'll worry about how those work. What's going to work well with this business?
The 1,103 plus 2,639, whatever
Yes.
that number is, and
What works well with this business?
The n factorial
Yes.
fourth.
And then the only thing we have left is the 396 business.
We can separate the bottom part
Jeff,
out to
dadgummit.
396 to the 4n
Yes.
times 396 to the 4n.
Now, I'm sorry I didn't do this before, but I'm always a fan of less writing. But you guys see how that makes it a lot? It actually just made 4 separate problems. I can focus all my attention on each one. You don't feel like you're doing all this crap on the top and all this crap on the bottom. You're like, God damn you, Jeff. You're still gonna get goddamn me, but you're maybe a little less clenched teeth. Can you guys just do the first part of that? The 4 stuff, the 4 ends business, the factorial?
I'm supposed to tell you or just write it down?
Just write it down. Sorry. Really? Yeah. See how disgusting that part looks? It's easy as shit. Let's see if you guys agree with me in a minute. Okay, somebody now tell me, what are you putting on the top?
4n plus 4 times 4n plus 3 times 4n plus 2 times 4n plus 1 times 4n factorial.
Oh man, I really petered out at the end. Let's see. It sounded like you guys were doing some ritualistic thing. There's so many.
Well, you
demons
asked
of
for
math.
the answer.
That's what chalk is. We need chalk to summon the demons of math. We don't have chalk anymore.
We need chocolate.
We do. Little demon image on the anyway. No summoning demons today, guys. I'm sorry. Look at the 1103 business. Yes? What's the degree of both of those?
1,
1. So what is the limit?
1.
Because it's just the ratio of the coefficients, and they both have a truth value. Who cares? 27 who cares? They both have the same stupid number. So as ugly as that looked, it don't do shit to us. Yes? I know. So a lot of people give up because it's like, holy shit, look at all that crap in there. But that's what happens. Yeah? So real quick, you should have done enough by now. If I have an n plus 5 term in it, there's going to be an n plus 6 term, and those limits is going to be 1, isn't it? That's going to work every damn time there's a polynomial piece. Its other thing is going to make the limit 1. Yes?
Yeah.
Maybe? Okay. So there you go. There's a beautiful example. Disgusting ass numbers. Who cares? The limit's 1. Yay! Now, the trippy one is this dude. So here's where you got to be careful. I'm not going to make you write this 4 times, but inside this, how can I rewrite this?
N plus 1 times n.
Is that cool? And do you guys see what is this raised to?
The
The
fourth
fourth.
power.
So I'm going to bring this in. Is that cool?
Yep.
And then this is raised to the 4th power.
Mhm.
So this cancels. Left with this, yes? Do you guys see that?
Yes.
Maybe. And then what happens here? This little 6 has an extra freaking arm or something. It's weird.
You got a 1 over.
How many 396s cancel?
4n.
4n of them. So how many's left?
4
Where?
on the bottom.
There you go. Okay, that still looks gross, doesn't it?
And that's gonna go to.
Wait, did I not kill? Oh yeah, I didn't kill this yet. This dies, right? Die.
And
Okay.
that's gonna go.
Now let's collect what we got. Here, let's see. I'm going to write more than I normally would. 4n plus 4, 4n plus 3. Dear God, dear God, everybody. Do not multiply this shit out when you see that. Dear God, don't multiply that shit out, yes? What degree would this be if I did? That's all you need to know. I don't give a shit what it is. All I care about is what degree will it be. Yes? What? Sorry. Over n plus 1 to the 4th. And then this is times 396 to the 4th, yes?
Yep.
Si, senorita. Now, if I let n go to infinity, Can somebody tell me what the coefficient of the n to the fourth would be? Will be 4 times 4 times 4 times 4. 256.
Oh.
What would the coefficient of the n to the fourth be on the bottom? No. 396 to the fourth. Doesn't matter what that number is.
Yep.
What matters is that number is less than 1. Because what test are we applying?
The ratio.
So whatever answer I get, if I wanted to converge, it's going to be less than 1. And they told me it converges. They just wanted me to verify it. So that problem was a lot easier than it looked. It was still a lot of writing. But the math required wasn't that bad. But it is a bit of writing. The numbers got big. Who cares? Because at the end of a ratio test, it doesn't matter what the number is. It just matters, is it bigger or smaller than 1? That's all that matters. So I don't want to see what the number is. It's just less than 1. Yeah? So therefore, part of it, we verified that it does converge. We didn't prove it's 1 over pi, and we ain't going to do that shit because we ain't this guy. I've seen some of his proofs, and they're trippy as shit. So I'm not going to do that to you. What was the part B? Oh, yeah. Can you guys, what would the first term of this series be? How do you figure out the first term of the series?
Plug in a 0.
Plug a 0 in for n.
You just get
What's 0 factorial?
0.
No.
4.
1. Didn't I show you guys that?
Oh, right, yeah.
Okay, 0 factorial is 1. 11 to 3 plus 0. So on the top we get 11 to 3. 0 factorial is
1.
396 to the 0. Oh, and then you got this shit out front. Yeah. It's like, holy shit. So real quick, all we got was 11 to 3 on the top, right? Over 1, you with me? Who's got a calculator? What is 11 to 3 times 2 times rad 2 divided by 9801?
Times 2.
Yes.
318.
Now compare it to 1 divided by pi.
It's the same freaking thing.
Yeah, of course it is. Okay, good. It's,
Oh, because it's equals.
but I only took one term, yes?
Yeah.
Because, I mean, this big ass number means, especially this guy. If you let n go to 1, isn't this guy going to be huge, making the number really small? So it decreases fast. Alright, I'm sorry. It's just that the first term does a really good job because the next term is going to be stupid small. But how far does pi go? So if you wanted to get all the digits of pi, you have to go to infinity. If you want most of the digits that we care about for pi, you just have to take the first term. That's crazy. Okay. Maybe? Listen, if that was about the only problem that gave you trouble in that section, you're doing fantastic. This was supposed to be a little bit of a push. But you see how what was a push was getting over the fact that big ass numbers in there. Who cares? They're just numbers. They cannot hurt us. The functions are freaky as shit. Numbers don't do shit to us. Okay. Sorry, I'll come back. Don't remember where the other one was, but somebody can remind me if you want to see it. What else you got? Is there anything you want to focus on? Any specific things?
I think this is more of an algebra problem, but on 4A for the practice test, how do you like find the interval, like the balance of it, whatever it is, or like how do you check that?
Oh, what'd you get for the bounds? What'd you get for the?
-9 to 9.
Let me see if that sounds right. Yeah, I think it sounds right. You plug them in. So here's the thing you have to be really careful about. If you're plugging in a negative number to the n, you take a negative one to the n out. That is now an alternating series, yes? So you look at it like an alternating series. When you put a positive 9 in, it ain't alternating. So then you have to be a little more careful about how to evaluate it. Are you with me? So, real quick. So, Cash, how did you get those?
I did the ratio.
Ratio test, kick ass. Oh shit, I've already written all over that poor little piece of paper. So now, can everybody do this for me? could everybody please take this series and let's plug a 9 in first. Can you guys plug a 9 into the series? For the x, yes, that's what we have control over is the x. Plug a 9 in. Yep. Plug a 9 in for the x. And I'll tell you one extra little thing you can do on the bottom. Powers 1 plus 2n, you can break that up, yes? You add powers when you were multiplying, yes? So the first step is just throw a 9 in. On the bottom, how do I rewrite that bottom?
E to the 1 power times e to the 2n.
Kick ass. And what is 3 to the 2n? Because that's 3 to the 2 to the n. 3 to the 2. So we were going to say 3 squared. It's 9. So that's 9 to the n, yeah? You can see that. Just to remind you, can somebody remind me? If I had y squared to the 4th, what is that? Y to the 2 times 4, y to the 8th, yes? So if I have 3 to the 2n, that was 3 to the 2 to the n. Because I'm multiplying the powers. It must have been that. Or, to be honest, 3 to the n to the 2, but this is a better way to write it. So this becomes Jeff. These. And what I'm really looking for now is what this series is doing. And what does that series do? Yeah, because this n goes to infinity, so I can apply the test for divergence. So the trick is the boundaries for your interval when you do ratio test. Ratio test has no idea. That's why they're there. That's where it equals 1. Ratio test is like, I don't know. So you plug it in and you step back. You're like, what kind of series did I just make? Well, that one goes to infinity. It diverges. Similar thing's going to happen if you put the negative 1 in. It's going to be alternating, but then n plus 5 is going to go to infinity, so it diverges also. Is that okay? All right. Or you guys look like I feel. You're all like, please, go. Okay.
Can I see the top of the video?
No. Yes. That much there? Yes? So I just plugged a 9 in just to investigate what happens. Because the ratio test gave up. So I don't know. And we're like, look, ratio test and convergence. Maybe. So what I want you to have is a feeling that you know how to attack a problem. If you get a problem, you kind of know how to attack it. So what are you trying to look for? If I give you a series and I say, does it converge or diverge? If I'm you, I'm not going to do tests for divergence first, to be honest. Is it a p-series? Is it geometric? You know, I'm going to look for the simple ones that have really easy rules, yes? If it's neither one of those, then is it obviously like ratio tests? Are there factorials running around? Yes? And if it's not that, then I'm thinking, well, let me try the limit. Maybe it's a test for divergence. Yes? You guys see what I'm saying? That's, if I were you, that's what I would do. I mean, if it's obviously p-series or obviously geometric or something, screw the test for divergence. Just go right to that. If it's not, and then ratio test. I'm hoping if you guys do enough of those, you start to know what to look for. Ratio tests have factorials in them, they have n powers in them, blah, blah, blah. Maybe. By the way, I don't know how many of you guys have tried 5a out. I really hope not too many, because you're not going to be able to find like a series for that easily. It's just, I wanted to do square root because it's a very simple function, but you can't see the pattern too easily. Okay. So let me do this. I'm going to give you the answer key. And then you guys can let me know if anything looks bad. And let's see.
it just one thing?
No, it's two, but for some reason I'm doing this way.
Oh.
The quizzes are beginning.
Yes.
Okay. I came in a couple minutes late, guys.
Now, couldn't quite fit them all in front and back, so one more page. Crash. If anything looks wrong, it's possible some of these answers were a fever dream I had.
To look at 11, 8, almost number 30.
Yeah. You guys got it back there or no? No? Might be too many, but somebody can have extra scrap paper.
Get my practice test.
Oh, sort of. You can have this one, so I'll put it on.
Yay.
I came
Oh.
in a couple minutes late. Can
Yes.
I get the quiz? Like this?
Oh, yeah. Hold on. Let me put this up here. Elijah, which one? 11A, number 40 something? 30. And then let me catch up. Anybody else not get their quiz back yet? Okay. Where did I put them?
They were over there, I think.
Thanks, Sarah. In a fair world, you get a part of my salary, but too bad for you, it's not fair. Who else? Paul. You are. Everybody else got theirs? Okay. So let's see, let's look at this number 30, yes? Do you remember that right? I'm not good with numbers. I like the delayed reaction. Well, that's the first day of class. If I pass out not enough syllabi, I'm like, I'm not good with numbers. And they're all like, this guy?
Yes.
Ooh, yeah, I like it. So, okay. Again, you do not have to know ahead of time what's going to happen. But you guys, what do you know about natural log of n that I've said a few times?
Super slow.
Grows really slow. So the bottom is growing very slowly. What about b to the n?
Pretty fast.
If b is greater than 0, right? Now, real quick, if b is less than 1, b to the n is shrinking, yes? Okay, so this is a little bit tricky. So I can't really tell ahead of time exactly what's going to happen. But I know this thing is growing really slowly. Okay. So the question, of course, is find the radius of convergence. This is dependent on x. Can somebody tell me what kind of series this is? Power series. Yeah, it's a power series. Because it's x to the n fundamentally, so it's been shifted. Is that cool? So this is a shifted power series. Okay. So how do you think we're going to investigate how do you think we're going to get the interval of convergence? I could use root test if every single piece of this was raised to the, and that isn't. Do you know what the nth root of natural log of n does as n gets really big? And off the top of my head, I don't know either. Shit. I'd have to look at that. And I don't want to. So I'm not going to do root test unless every piece of what I'm given is raised to the nth power. Does that make sense? Because the nth root of function of n is trippy as shit if n gets big. I should do an example of that with you sometime, but you're all like, it's okay, Jeff. You don't have to do that. But just to really make sure you understand that it is trippy as shit. So I'm just going to do ratio test. And do you see how, even though I don't know b and a, the ratio test is going to be pretty straightforward because n plus 1 will just be bn plus 1. Now this is where things get interesting. This will be natural log of n plus 1. Can everybody write the ratio test for this? Just set it up for number 30. If you want to play along, you don't have to. You can do something else. Some of you guys will look at me like, I don't want to. Don't. That's okay. I would certainly consider that. So Elijah's got a good question, and let's see if you guys. So how's that look? Does that look okay? Hopefully it does. So what I normally do is I make one big fraction, just throw that up top. So then it's easier to flip the dude in the first place. Yes? And that some of this is normal shit. How many b's cancel? And real quick, if you want to, you can get all your b stuff together. You can get all your natural log stuff together. And you can get all your x stuff together. Get all your x's together and, well, that's terrible, Jeff. I was going to say kill some of them. So, how many b's cancel? How many b's cancel? N. How many are left? Where? Top. Because that's where there were more of them, yes? Good. And x minus a's cancel, so you're left with 1 on the top. So let's kind of collect what we have so far. B, x minus a, and then I have this funky shit here. Right? Okay. So how do I take care of this? And Elijah had a decent idea. What was your idea? L'Hopital's. Why does L'Hopital's work on this limit? Yeah, it's infinity over infinity. So L'Hopital's from his grave says, do my thing. Okay. Okay, L'Hopital. You're freaking us out, old medical dude. It's like Bill and Ted teach math. Old medical dude. So then we get, if I apply L'Hopital's to this, by the way, that's absolute value. So do you see how that is a constant according to this? So I can just pull it out so I don't have to worry about him. He's done. It's the absolute value of him though, yes? And then I can focus on this. What's the derivative of the top? Don't worry about the x bullshit. It's fine. What's the derivative of the bottom? How can I rewrite that? Huh? Sorry? Good. N plus 1 over n. And what's this limit? So I get this. Oops, I forgot that again. Now, real quick. This is a really good thing to remind yourself. You do a lot of work, you kind of lose what you're doing, and when you get there, sometimes some of you guys are like, oh, good, I'm done. Look at that. Equals this shit. That must be what I want. I'm done. I don't know what else you want. I can't do anything else. Of course, what did we just apply? Ratio test, and what must be true at the end?
That it has to be
Whatever
less
I get
than
has to be less than 1. Yeah. So then,
So you divide.
good. Divide by b.
And then since that's in the absolute value, then you have to do, it has to be less than negative b.
Negative 1 over b is less than
X
is less than,
one over B.
and then you can
add the A.
add A. I don't know. So you get A minus one over B is less than X is less than A minus plus one over B, yes. So what I'll need for you to do is to check the inputs. I agree. Yay. Huh?
No, I just raised.
Oh, what's up?
I was saying on the answer sheet, I was looking at it. It's dangerous, putting 0 exclamation mark. I know you.
Oh, yeah. Yeah. I always forget that when I teach the factorial. I've got to be careful now. Where? Oh, here?
Yeah,
Okay, yeah.
you underlined it too.
I did. I totally did. I'm like, this is what I mean. I will go to my grave meaning this. And Cash is like, you cooked yourself, John.
So is it 1 or 0?
Yeah, it's 0. Yes. So in this case, the exclamation mark is just an exclamation mark. It's not a factorial.
It's 0, not 1.
Yeah. Good point. I appreciate that.
Yeah.
If nobody said that, I would be concerned. So depending on what level of math I'm teaching, I have to be careful how I write my notes. You know, I'm like, oh, look, it's this. And I'm like, what is that? Oh, shit. Then you start to wonder about, well, when does the question mark mean something else, Jeff? What level of math is that? Maybe. Well, yeah. Oh, yeah, you can go. It's fine. Don't worry. Do you have questions? Yes. You good? Okay. Do you have any, like, practice test stuff, quiz stuff, homework stuff?
Can you do the first one on 1110 that you signed? It was number 4. I'm not 100% sure how to start that.
Now, what percentage sure are you? Are you not gonna- Oh, man. So, we've already given you the form. So, okay. What is A? What are they building? Yes. And they've already done all the work. They did all the derivatives. They put 4 in each one, and then they got.
Oh.
So you just have to throw that in the summation. You're done. They've already done. Now be careful.
Oh, okay.
You remember, it's at the nth derivative divided by the n factorial times x minus a to the n. Yes.
Okay. See,
So this piece they've done completely for you.
I think I was interpreting it as like
Undo it.
F of 4 or whatever.
Oh
Where
yeah.
it
Well,
was
it
like-
sort of is, but it's all the derivatives of 4.
Okay.
So they did all the work.
So I just have to put that.
You just have to
exact
plug
thing
that piece
into-
here into this form. Yeah.
Okay.
Yep.
it here, Jeff?
Yeah. Put it there. Yeah. Cool. Thank you. Oh,
I don't know why, but 11.9 and 11.10 really give me little problems.
That's understandable. Because they are
The rest
very
of-
different
well,
from
the
what
rest
you're used
of
to.
it's The rest of it's been completely fine, but then I got to 11.9 and everything was like,
It's very different. It's built off of stuff that's not that bad, but it's using it, it's throwing calculus in there. Yes? What happened? Oh, yeah, it's all right. You get the full, be ready next time, yeah. Okay.
I hopefully have you.
We'll see, I'm not sure, I'm not teaching it next semester though. Schedule's up, take a look, I'm not teaching 280 next semester, yeah. I'm teaching 180, which won't help. Take a look at who's teaching, I can tell you, give you clues who to take.
aren't you doing the 180L again?
That's not gonna exist anymore. That's being replaced with Sissel, which is gonna be an almost all-day open lab with instructors in it every hour that you're gonna have access to. And it's gonna be a lot better than
Okay, I
what
was
the
like-
180L was.
Since you did create my.
Yes, I have it right here, so if nobody has questions, I could grade it right now. If you wanna wait, or it's up to you.
I mean, sure. Yeah, because I was just gonna ask because.
I felt bad.
Corrections and stuff like that.
Let's see, where did I put?
Um,
Oh, here, there.